Section 1. Understanding the basics. What is linear regression? Have you ever wondered how scientists and analysts make predictions about the future? How do they take complex data and use it to understand trends and make informed decisions? One powerful tool in their arsenal is linear regression. Linear regression is a statistical method that helps us understand the relationship between two or more variables. Imagine you're trying to predict how many scoops of ice cream a vendor will sell based on the temperature outside. As the temperature rises, you might expect ice cream sales to increase as well. Linear regression helps us quantify this relationship. It allows us to draw a straight line, or in more complex cases, a plane, through a set of data points, showing us the general trend and allowing us to make predictions. This line is more than just a visual aid. It's a mathematical equation that represents the relationship between the variables. This allows us to make predictions about one variable, like ice cream sales, based on the value of another variable, like the temperature. Section 2. Simple linear regression. One variable, one relationship. Let's start with the simplest form, simple linear regression. In this case, we are only looking at the relationship between two variables, one independent variable and one dependent variable. Think back to our ice cream example. The independent variable is the temperature, which we have no control over. The dependent variable is the number of ice cream sales, which we believe is influenced by the temperature. Simple linear regression helps us understand how much the dependent variable, ice cream sales, changes for every unit change in the independent variable, temperature. The steeper the line, the stronger the relationship. This information is incredibly valuable for making predictions. If we know the temperature, we can use our linear regression model to estimate how many ice cream cones the vendor is likely to sell. Section 3. Multiple linear regression. Juggling more variables. The world is rarely so simple that it can be explained by just two variables. Often, multiple factors influence an outcome. This is where multiple linear regression comes in. Imagine trying to predict a student's exam score. Factors like study time, attendance, and previous grades could all play a role. Multiple linear regression allows us to consider all these variables simultaneously. Instead of a straight line, we now have a multi-dimensional plane representing the relationship between all the variables and the outcome we're trying to predict. This allows for a much more nuanced and accurate prediction model. Section 4. Predicting the future. Linear regression in action. The beauty of linear regression lies in its ability to make predictions. By understanding the relationship between variables, we can make informed guesses about what might happen in the future. For example, businesses use linear regression to forecast sales, helping them manage inventory and resources. Economists use it to predict economic growth based on factors like unemployment and consumer spending. In healthcare, linear regression can be used to predict the progression of diseases based on patient data, allowing for early intervention and potentially life-saving treatments. Section 5. Real-world applications, from house prices to medical breakthroughs. The applications of linear regression are truly vast, spanning across numerous fields and industries. In real estate, it's used to estimate house prices based on factors like location, square footage, and amenities. Financial analysts use it to model stock market trends, helping investors make informed decisions. Linear regression is even used in machine learning and artificial intelligence. It forms the basis of many algorithms used for tasks like image recognition, natural language processing, and self-driving cars.